Please welcome to the stage Koen Biggelaar, Head of Solution Architecture for Amazon Web Services Energy Practice.
To pronounce my name correctly if you're a non-Dutch native speaker. So if I really intend to be a rock star, I think I need to change my name. So I also want to thank everybody actually for the opportunity to speak over here about digital innovation and the OpenEarth community. And following up on the previous speakers, I've got two questions for you. So question number one is, who of you is convinced about the need for change in this industry and the opportunity we have as a collective to make it actually happen? And the second question I have is actually even more important. The second question is, who of you is making an active contribution and is really going to make this change happen? I think that's what we need to do as a community with the OpenEarth community to make the digital transformation a reality. And in fact, when I was preparing for this presentation, I was really thinking about situations where technicians were driving 100K miles and they were doing physical inspections, or I was thinking about discussions that we're having with teams who were waiting for HPC clusters to become available for the seismic interpretations. Or we had discussions with like geophysicists and geologists who were spending 50% of their time just searching for the data instead of spending the time on valuable insights getting out of the data. And these are just some examples. And what I was thinking is, these are examples for tomorrow's vision, but it could be examples of today's reality. And I really believe that with the OpenEarth community, we have the opportunity together to really truly innovate and make the energy sector more efficient, more safe, and also more fun to work in. And that's what I really want to talk about. So again, my name is Koen van der Biggelaar, and I lead a team of solutions architects, and with the rest of the AWS team, we're helping our global energy customers with digital innovation in its broader sense. And I really want to talk about how we do innovation at AWS, what our platform is, but most importantly, what we currently are doing with the industry at large to see some examples that turn that into a reality. And I also want to thank Halliburton Landmark for the opportunity to speak here and sharing some of these live examples. So now if we really take a moment to review the vision of the OpenEarth community, it is really all about helping others to innovate. It's really about enabling others for co-innovation and not just like a happy few can innovate. It should really be as simple as that anybody who has a good idea is inspired to work on it simply because you know there's the infrastructure for you to support it. And when I talk about infrastructure, I'm not just talking about storage, machine learning, or compute. What I'm talking about is really the underlying structure that supports your innovation. And actually with that, I'd like to show a quote from Jeff Bezos. And this quote is really describing how we at Amazon and AWS think about innovation. And obviously, this can be innovation within teams, within Amazon and AWS. But most importantly, it's innovation that we try to enable with developers, businesses, and enterprises outside of Amazon. So the key point here is how to enable others to innovate. And again, innovation is more than just thinking about ideas or writing code. And what we've learned, in order to have successful digital innovation making a meaningful impact, it's really important to organize yourself for digital innovation. And what we've learned is there's 4 key ingredients to make digital innovation a success. And these 4 ingredients are all interconnected. If you take one out, you get a different result. And at the same time, if you do this well, what you're actually doing is you're taking innovation to the edges. So you're creating startups in your own company, accelerating your pace of innovation. So what you're doing is these startups at the edge, taking their own decisions, driving innovation forward. What we do with the mechanisms is our mechanisms are designed around the customer, are designed around working backwards from the customer and making the customer the starting point and the finish point of everything we do at Amazon. So every customer-facing product that we have is using this working backwards process. And we use this working backwards process to really, really make sure that the customer is the center of everything we do. And the second thing is, so if you have the opportunity to build, you need to give builders the architectural platform that they can actually do the build. They can actually have the tools and they can make things happen. What we've done with AWS is we've removed the concept of a gatekeeper. So removing the concept of a gatekeeper, there's no waiting line to use anything in terms of storage, compute, or machine learning, and this fundamentally changes the way people think about innovation. Why? Because now, if you have this single idea, you can actually make it happen because the infrastructure and the processes are there to make it happen. And then you need a culture. And we talked about leadership, and we talked about how to organize ourselves. And what we do in Amazon, we have what we call leadership principles. We have 14 leadership principles, and they range from customer obsession, invent and simplify, deliver results. And what they do, they drive all our day-to-day actions. They drive how we hire, they drive how we do performance reviews, they drive how we hire teams, and most importantly, they make sure that everything we do is with a customer in mind. So we really hire builders, we hire people who really like to invent on behalf of the customers, who are looking at customer processes, at customer situations, and see what can be improved here. And also, we believe that the launch of a new product or service is a starting line, not the finish line. And then you need an organization that's supporting that. You need the organization that supports these builders to build. And what we do is we use the concept of a two-pizza team, the 2 US pizzas. And that means that we have teams of approximately 8 to 12 people. They work together, and they work together in an agile way, and that team has full autonomy and ownership of everything they do. So this is what I call this small startup in your company. And then culture and organization, there's one additional concept to keep in mind. If you really want to do innovation, you need to understand that innovation and failure are inseparable twins. What I mean by that is, if you know the outcome of an experiment, it's no longer innovation. So what basically means is that if we have a failure in AWS, we use it as a learning experience moving forward. So just one additional slide on the working backwards process. So it's really a process, and every customer-facing product or service we develop across Amazon is using this working backwards process. And the central artifact here is what we call the PR FAQ, the press release and the frequently asked questions. And this document is a document you write when you have an idea. It's dated in the future, and it's describing the actual business value that you're going to provide. And there's 5 key questions that you need to answer if you want to write a good PR FAQ. Number 1, who is my customer? It can be an internal customer, it can be an external customer, it can be a partner. Clearly define who is the customer. Second thing is, what is the actual problem or opportunity that you're going to address? Be as specific as possible here. The third thing is, what is the single most important customer benefit of your idea? And number 4, how do you actually know what your customers need or want? Did you do any market research, anything else? How do you know? What are your data points? And the last one is, how does your customer experience look like? How is your customer going to consume your service? How does a customer is going to be charged? What happens if there's an issue? How did it contact you? And I can tell you out of experience, it's costing quite a lot of time writing a good PR FAQ. But at the same time, it will save you and the teams a lot of time because now all the teams are aligned on the outcome and all the teams are aligned to the actual customer value that you're going to provide. So in Amazon, we use customer feedback to drive our services. And I think roughly over 90% of our new services comes from customer feedback. An example is that we had discussions with customers, including many who came from the oil and gas industry. So if you have been involved, thank you. We're giving the feedback that, hey, we've got this AWS platform that's absolutely great. Is it possible to extend the AWS capabilities to my data center? So what we've done at last year's reInvent in 2018, we have launched AWS Outposts. And what AWS Outposts is doing is bringing you native AWS services and infrastructure, and you can locate it in virtually any data center, co-location space, or on-prem. And what it does, it gives you a set of AWS services using the same AWS APIs, using the same infrastructure, so you can truly have a hybrid experience across AWS and your on-prem environment. Outpost is really designed for connected environments, so it's used to support workloads that need to remain on-premise due to low latency or local data processing needs. And actually, this complements the Snowball and Snowball Edge. And Snowball and Snowball Edge are used for disconnected environments. And they provide storage, and Snowball Edge is providing additional compute, so you can use a Snowball Edge for local data, and you can use it for running your machine learning models. So I'd like to give you one example where Snowball Edge has been used, and that's with in situ. What the situation here is, it's about physical inspection of remote sites, and this example is in Queensland, Australia. And technicians were traveling long distances, and, well, obviously that can be costly, and it can create safety risks. So what happens is they're now using their drone, the Scan Eagle product, and it's linked to the AWS Snowball Edge. And in the end, it reduces the operator travel by up to 500K miles annually. So think about it. How much reduction you will have in the travel, how much safety you have improved, and also the reduction in your environmental impact. So it's pre-configured with their proprietary model, and it creates it creates a 3D model of the infrastructure on a remote location. Data is then pre-processed, data is validated on the Snowball Edge, and afterwards the data can be transferred to the nearest AWS region. We currently have 22 regions around the globe. I think it is important to describe what we call a region. So a region is a completely independent part of the AWS cloud. And each region consists of multiple availability zones, typically 3. And each availability zone consists of one or multiple data centers. And the availability zones are designed in such a way that they provide physical redundancy, resilience, and they enable uninterrupted performance if one of the other availability zones becomes unavailable. And the availability zones are interconnected using low latency links, so you can build high available applications within a single region. So we recently announced the Middle East region in Bahrain, and we have upcoming region launches in South Africa, in Italy, and in Indonesia. And then in addition to the regions and the availability zones, we have 180 points of presence, the edge locations, which is used for compute at the edge, is used for our cloud delivery network and DNS services. And that brings us to our own innovation. So since the inception in 2006, we have accelerated our pace of innovation. And last year, we had approximately 2,000 new services or new features being added to the platform. Outposts was one of them. So actually, the list is ever expanding. Currently, we are up to 165 AWS services. And it's always difficult to present it on a single slide. So I hope you can read it in the back. But this slide is describing the different functionalities of the AWS platform. So in green at the bottom, you see the core infrastructure, the regions, the availability zones, and the points of presence we just discussed. Next to that are the core services, compute, storage, networking, and databases. And basically what we fundamentally believe is customers should have choice. You should have the choice to choose what is right for them. And you can use as much or as little AWS service as you need in order to achieve the outcome of your project. So you can use the lower level core services or the higher level abstraction services. So basically this is addressing what the Gartner speaker was describing earlier about the different types of developers here. And also this is where the people services come in. So on top you see the people services coming from the partners and AWS. That includes my team. We've got a dedicated team supporting oil and gas customers. We have all these discussions about how to use these services, building HPC for seismic, building data lakes, doing machine learning for predictive analytics, etc. And if we just stay with the machine learning for a second, so you can use the higher level AI services for speech, for text, forecasting, and recommendations. You can use SageMaker to deploy your own models, or you can use the popular open source frameworks, MXNet and TensorFlow. And Netflix, like the example was provided, so Netflix is using TensorFlow on AWS. Actually, it's interesting to know that approximately 85% of all the TensorFlow projects, they run on AWS. But I think what's most important here is that companies can use these services to build whatever is needed. One example is one of the breakouts 2 days ago with Wintershall in Germany. We're working to analyze various drilling and engineering parameters to better predict our future results. And it's really facilitated them and helped them to optimize the drilling operations. And they're really thinking out of the box, using the machine learning, using image and facial recognitions. If you haven't seen it, it might be on the video. So another example on machine learning is a case where a customer had a 5-year backlog with the asset integrity repairs for the offshore platforms. And what they did, they hired an external contractor, and they had inspectors, and they provided a list of everything that had to be replaced. But hey, if you get a 5-year backlog, the model is effectively broken. So what this customer decided to do is to take a risk-based approach where corrosion comparisons are made between the years. So what's happening now is that image recognition is used to compare how quickly is the corrosion advancing over time. And this then is determining what assets need to be replaced. So the end result here is, instead of waiting for a report from the inspectors, they can now see which one have not advanced, so can be deprioritized, and for which one the corrosion has advanced, so they can be prioritized and the assets are going to be replaced. And this is a similar example where a D-Link was using their cameras. So over here you see an example where images from the camera are fed into a TensorFlow model. And this model is trained, and then effectively the resulting model is put back onto the camera using Amazon IoT services. So the actual machine learning inference is running on the camera itself. So what we have a smart device, an IoT-powered camera. The camera is turned on. Camera is a high-precision camera, so it can detect all the components like the clamps on the tubes, but also, as it is high precision, it can detect speed, lengths, and distances. So what we see here, once the machine is finishing attaching the tubes, the ML model is now able to detect engineers in the keep out zone automatically, and when this happens, the appropriate team can be alerted. An example from downstream. So over here is BP, and BP is using Spiral Suite for their refinery planning. And what was happening is they were facing challenges with optimizing their Spiral Suite, and when they were doing like a simple analytic, 146 cases, it took them up to 7 hours to complete. So what happened is they decided to migrate to the cloud, and once run in AWS, this same calculation took them 4 minutes to complete. These are simply due to the fact that you can run all these calculations in parallel. So what do you think about the impact here? In the original situation, you literally could go home and spend a good night rest and come back for the calculations to finish. And now you've got to hurry up to get yourself another cup of coffee. And this really allows BP to adapt to market change in real time. So they can make better decisions, higher confidence levels, and lower risk. And why? This is simply because now you can do more calculations in the same time to validate your results, and you can explore multiple options. And of course, you only pay for the resources where and when they're needed. You scale up and you scale down. There was some talk this week about the Open Subsurface Data Platform. And the presentation yesterday from Johan and Chandra of the demo, and I quickly want to talk about it. So the Open Subsurface Platform is a standard for a subsurface data platform, and it exposes a set of APIs for search, for ingest, and for delivery. And it really allows to have operators who have access to a standard data platform that can be used for the subsurface data. It supports wells, well logs, curves. It will support seismic in the near future. And as it supports a standard set of APIs, it really allows application developers to develop an application which can run on any OSDU compliant deployment. So as AWS, we have been involved with OSDU from the start, and we're actively working with the Open Group OSDU members to make OSDU a reality. And for the current OSDU release, which is based on the work that we did with Shell, so we are making available the OSDU Release 1. And the OSDU Release 1 can be installed in any AWS customer environment, and it's using all of the AWS native services, things like API Gateway, Lambda, so it's a serverless deployment of OSDU. And in addition to exposing the APIs, we also created a portal. And yesterday you've seen the demo that Chandra created in terms of having the Halliburton logo appearing in the portal. Why? Because the applications are integrated with OSDU. So the user can select the applications and move to the applications, EDM and borehole data management. This is all created using the OpenEarth community, and that's what I want to get to now. So the OpenEarth community, we've been working with Halliburton and the community to create a platform for OSE. And it's a publicly hosted secure cloud platform, and it's offered to Landmark and its customer to enable digital innovation. So it's accessed using your own desktop, and you have access to the environment in OSE using a virtual workstation in AWS, and it's got developer tools such as Eclipse and Visual Studio pre-installed, so you're ready to go. From a security perspective, everything is secure. You only have access to your own environment. You can put data in the environment, you can take data out in the environment, you can share data within your project. And the underlying architecture of OAC is built on native AWS services. So the OAC APIs are powered by Amazon API Gateway. And this includes APIs for provisioning and managing projects, user management, workstation management, and reporting. And under the hood, the API Gateway is calling a number of AWS Lambda functions, serverless compute. Then the deployment, the build, and the automation, they're really performed using Jenkins, and again, a lot of AWS Lambda functions. And the underlying applications can be deployed on containers, on Kubernetes, using the Amazon Elastic Container Service for Kubernetes. And one additional service I'd like to highlight here is the Amazon Guard Duty in the security box. So what Amazon Guard Duty is doing, it's a machine learning powered intrusion detection system. So it protects the OpenEarth community. On the database side, you see at the bottom of the slide Amazon Aurora. And Amazon Aurora is part of the Halliburton Landmark's move to open source databases. So Amazon Aurora supports Postgres and MySQL. It's 5 times faster than standard MySQL and 3 times faster than a standard Postgres deployment. And perhaps as most important, it's a native cloud database. What does it mean? It uses a distributed, fault-tolerant, and self-healing storage system, which auto-scales up to 64 terabytes. And because OAC is running on the AWS global infrastructure, the functionality for teams to work together is natively built into the platform. So that applies to industry partners, it applies to developers, it applies to solutions integrators, and they can use all of this functionality to work together. And actually, like Chandra was mentioning in the keynote at the beginning, the functionality for having your AWS experience provided in different regions across the world is now provided. That includes US, Europe, and APAC. And with all of this, we see different patterns beginning to develop. So one of the patterns that we're seeing is co-development. So co-development between a customer and Halliburton Landmark. One example here is, over the last couple of months, there were a dozen companies who were seeing limitations in their seismic interpretation workflows. And one of these customers, they saw the seismic data really getting so large that it was not sufficient anymore to put it in the local data storage. And they were using proprietary fault attributes, and also they used algorithms, and the processing capacity on-prem was not sufficient to do so. What did they want to achieve? What they wanted to achieve is a 5x improvement in a seismic interpretation time. So what they did, they connected with Halliburton Landmark, and they started a private OAC project. And they started to discuss how can we load the data, how can we use our proprietary fault attributes, and how can we basically speed up the seismic interpretation. So the solution to this challenge was using the Decision Space 365 seismic engine. And basically what it is, under the hood, it's an on-demand processing engine. It's powered by Amazon EMR, and Amazon EMR is a managed service for running Apache, Spark, and Hadoop. You can use it to quickly analyze large amounts of data. You can bring your own algorithms. And it really provides scientists who want to quickly scale up and run their prediction models. One interesting point here as well is that spot instances were used. What is spot instances? Spot instances is AWS unused capacity, and that's offered to customers at a significantly reduced rate, which can go up to 90%. So think about it. Massive cost savings here. The second pattern we've seen is where customers would like to connect new tools to existing data. So over here is an example where an NOC wanted to create a dashboard, bringing together different data sources from the SIS. And what happened is this quick project generated this dashboard, and this data was previously not available, or it would take weeks or sometimes even months to be generated. So now they've got this dashboard, publishing all the data, and it publishes all the water usage data, and it can be used to ensure compliance with the environmental laws and our usage quota systems. What's also interesting for the community here is that this project is now working on an SAP connector that will be contributed back to the OEC community. There was also an IOC using the same pattern who wanted to improve their workflows in the Wells program. And they engaged as well with a smart platoon team on a private OEC project. And they were putting together different data sources, the data reconciliation, data consistency, and now the people in the field, as well as the office workers, have access to the same data at exactly the same time. So what we believe, this is really the starting point of our digital innovation. These are some practical examples where we've seen successes, and I think we really have the opportunity as a team to work together to make that happen, and as Amazon, we want to be a partner here. So you can connect with your AWS account team, or we've got the applicable email address, oec@amazon.com. And with that, I'd like to thank you for your attention.